Now let us study the carboylamine reaction. That is the fourth reaction. Carboylamine reaction. Carboylamine reaction. This is a unique reaction for primary amine. For example, let me take RNH2, primary amine, that reacts with the chloroform CHCl3 plus 3 moles of KOH. When it is heated, you are able to get isocyanide, that is NC. This is called carboylamine, plus 3KCl plus 3H2O. Actually, it gives us some fishy odor. So, based on the foul smelling liquid, this is the carboylamine. So, this is one of the test for amines, primary amines, carboylamine. There is another popular reaction called diazotization. That is a reaction with nitrous acid. It gives a diazotization reaction. It forms a diazonium chloride. For example, C6H5NH2, aniline, in presence of sodium nitrate and the HCl, and the temperature should be 0 to 5 degrees Celsius or 273 to 278 Kelvin. It gives C6H5N2Cl with plus and minus. So as I already told you, N plus means azanium chloride. Now there are two nitrogens, so diazonium chloride, and it is based on benzene, so it is called benzene diazonium chloride. And this reaction is called diazotization reaction. We'll be exclusively studying about the diazonium as a separate topic. Now let me proceed with the next one. The secondary amine, tertiary amine, they react differently, but primary amines will behave like this. Then a reaction with Hinsberg's reagent. This is another salient feature of amines, particularly primary amine. Hinsberg's reagent. What is the Hinsberg's reagent? Which is nothing but benzene sulfonyl chloride, that is C6H5SO2Cl. So let me consider this benzene sulfonyl chloride, that is S double bond O, and Cl. And that can react with aniline, a primary amine, or even you can take C2H5, ethylamine in this case, so that you are able to get this HCl is removed, so that it forms S double bond O and NH, then C2H5. So this is called N-ethyl benzene sulfonamide. Sulfonamide. So this is regarding primary. And the same reaction, this is actually soluble in alkali. This is soluble in strong alkali like NaOH or KOH. So they form sulfonamides. This is called N-ethyl sulfonamide, benzene sulfonamide. Then similarly, now the same compound reacts with disubstituted, that is secondary amine, C2H5, C2H5. So this is the secondary amine. So once again HCl is removed. So in this case it gives HCl C2H5 C2H5. So this is called N N diethyl benzene sulfonamide. Benzene sulfonamide. Okay. One, you should have a double bond here. Double bond four. Okay. Tertiary amine do not react. So this reaction is helpful to distinguish the primary, secondary, tertiary, and this is not soluble in alkali because there is no replaceable hydrogen. So in this case, they are replaceable. For example, this H can be replaced by sodium, so it is soluble. But there is no replaceable hydrogen here, and that way it's not soluble in alkali. But in case of tertiary, this C6H5 SO2Cl with the tertiary amine, no reaction. Yes. So this property is helpful for us to distinguish primary, secondary, and tertiary. Now, electrophilic substitutions. As you know, electrophilic substitutions, so we have nitration. What is that? Sulfonation, halogenation, acylation, alkylation, etc. So all of them will give, we know the general electrophilic substitution. Okay. For example, nitration means that is you have this NH2. Okay. So this can be an ortho and para. Okay. So ortho and para. Excessive bromination gives ortho para dibromin, aniline. And similarly, you have got sulfonic acid. That is NH2 SO2 OH. This is called, what is that? What do you call this one? Huh? Sulfonilic acid. Sulfonilic acid. This is called sulfonic acid. And this is aniline. So sulfonilic acid. And if there is no amino group, then it is called benzene sulfonic acid. And it can also be called para-amino benzene sulfonic acid. Simply called aniline sulfonic acid or aniline sulfonilic acid. And it can form on nitration, which is nitration. Usually nitration is done by nitration mixture, HNO3 and H2SO4 concentrated called olein. So it can form what, that is para group and meta group also. Ortho, para, meta, this is NH2. What is this? NO2. You are able to get 50% of para, and meta is also available here. So NH2, and here you can have, this is meta, this is para. So in meta you have got almost 47%, but ortho is less. So that is around 2% only, ortho. So 2%. So mention this. This is very important. And this aniline can react with NH2. That is acetylation. Acetylation means we can put CSCCOCl or CH3CO twice, CH3CO twice O. Otherwise CH3COCl. So either of this can act as acetylation agent, so that you are able to get acetonylide. So this is a very specific compound. This is known as NH, and this becomes COCH3. So this is called acetonylide. Acetonylide. And when you put nitric acid, then you can have para-nitroacetonylide also. Then sulfonation. Sulfonation will give you sulfonilic acid. NH2. So on reaction with sulfuric acid, usually sulfuric acid can be written as HOSO2OH. So here this H is replaced, and that is why you are able to get SO2 SO2OH. Okay, so OH is released, SO2OH. So here you can have NH2, and this can once again join with the H2SO4, so it becomes NH3HSO4. It is called anilinium hydrogen sulfate. This is plus, this is minus. Anilinium bisulfate or hydrogen sulfate. And then this on heating gives this SO3OH will come here. SO2OH will come here, so that you are able to get NH2, and para attachment is there. So you can put SO2OH or SO3H also. This is known as sulfonilic acid, and most of the drugs are based on sulfonilic acids. And in fact, it can form beautifully zwitterion also. It can undergo. Zwitterion means a dipolar ion. That is, it has got both a single identity with a positive and a negative. A cation and anion exist together. That is called zwitterion. It becomes NH3 plus, and here SO2 or SO3 minus. This is called zwitterion. Aniline will not undergo Friedel-Crafts reaction at all because for the formation of salt with aluminum. And finally, let us discuss about the diazonium salts. So this is a very famous compounds in drug industry as well as color industry, dye industries also. So let us have the benzene structure like this. Now you have N and triple bond N. So you have plus, and here you have minus. Now what happens? Not minus, the electron. So this can, and this is called, what is that? Benzene diazonium cation. And when you combine with the chlorine, it becomes a diazonium chloride. So this is diazonium. This can undergo a reaction like this. For instance, this can go here so that this becomes N minus and this becomes double bond. Then we have, okay. So in order to compensate this, this will go here so that it becomes a double bond here. Okay, and this one, right? So this is plus, and again you can travel like this so that you are able to get double bond N minus plus, and here this becomes plus, and again, so this will come here, so plus, so likewise it goes on. So this is called diazonium. Arene diazonium stability is explained by this resonance. What do you call it? Arene. Arene means benzene. Diazonium stability. So this illustrates the resonance structure of diazonium salts. Usually, nitro compounds they react with sodium nitrite C6H5 NO2. Nitrobenzene react with HNO2 and HCl at 0 to 5 degrees Celsius. It becomes C6H5 N2Cl. This is benzene diazonium chloride. And this is capable of developing various types of reactions. So let us discuss about this. For example, this C6H5 N2 X minus or Cl. Okay, so this reacts with Cu2Cl2 cuprous chloride in presence of HCl. It gives C6H5Cl, nitrogen is liberated. So you are able to get the respective halo arenes. If you replace by bromine, you will get the bromobenzene and similarly cyanobenzene. Halo, actually halo benzene halides. C6H5Cl, that is chlorobenzene. And similarly, you are able to get Gattermann reaction also. What do you call it? Gattermann. So these are all very popular reaction with the AR. AR means C6H5. So C6H5 N2 X minus. You can put the CLB or whatever you call it. So that in presence of copper and HCl, then you are able to get C6H5 the respective halogen. Suppose Cl means Cl, okay, plus N2 plus copper X, okay. So this type of reactions are called Gattermann reactions, and the replacement by iodide is called Sandmeyer reactions also. And finally, you have coupling reactions. They are very, very popular, and they are called azoic colors. For example, let us have benzene diazonium chloride, N2Cl plus. And when you have got any um, coupling reaction, so the para position is attacked here. So OH, and this is H. This is phenol, and this is benzene diazonium chloride. So you are able to get a diazo coupling reaction. So it becomes N2 and Cl is removed, so that you are able to get a compound like. So this is called diazo compound, diazoic colors. By changing the substitution, you will get the different colors also. Deep colors are obtained. That is because of alternated double bond, that is called conjugated double bond. So whenever conjugation is there, you will develop deep colors. So you can find here double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. So likewise, so because of alternate double bond, conjugated bonds are there. So you are able to get deep colors. So that is the specialty of this compounds. Okay. So with this, we have completed the amines. And before that, you should know something about amino acids also. Take down. This is CH3COOH, and the function group is COOH. This is alpha carbon atom. When alpha hydrogen is replaced by ammonia, then it's called amino acid. So this is known as alpha amino acetic acid. So this is helpful in forming biomolecules. That is the fundamental unit of proteins also. So about which we will be studying in biomolecules. So this is also called alanine, not glycine. This is called glycine. Alpha amino acetic acid. That is, this is alpha and amino. So this is glycine. And this also undergo zwitterion. For example, NH3 plus CH2 COO minus. So you are able to get the same zwitterion here also. And there is one more. Likewise, we have got around 20 amino acids. So here we have, let me CH2 instead of CH. So this we know, NH2 CH2 COOH. Now we will have CH CH3 and NH2. What do you call this? This is also same alpha, because this is alpha. Okay, 1, 2, 3. So propanoic acid. So 2-amino propanoic acid. That is called alanine. So this alanine is asymmetric. It has got asymmetric carbon atom, so optically active. So in among 20 amino acetic acids, one is optically inactive, other remaining optically active because of presence of C asymmetric carbon. Now the combination of these amino acids can result in peptides. So for example, when two molecules of glycine combine, they are called glyclide. When the two molecules of alanine combine, it's called ala-alan. Sometimes a gly-alan. So likewise, it goes on, and that is why you are able to get different protein molecules, biomolecules. So they are all called polypeptides, about which we'll discuss under biomolecules.